Hello everyone, we are a team of two, my team member Koshki and myself Anmol. We are going to build our own portfolio web application with an integrated RAG chatbot. This final project showcases our skills, work experience, and projects, providing an interactive and engaging experience for visitors like recruiters using advanced AI techniques. This is an overview of today's agenda. We'll go through introduction. We are focusing on developing our own portfolio web application and integrate it with a personal assistant chatbot. Our objective is to showcase our technical skills, work experience, and projects to provide an intuitive way to engage visitors like recruiters and provide interactive experience to them. So our scope is to design portfolio web application, which includes sections like About Me, projects, skills, education, work experience, certification, and contact form. We'll integrate an assistant chatbot for enhanced user interaction. It will help to answer questions related to my portfolio on the basis of my resume. Here is a project architecture. We use technologies like React, HTML, and CSS to design the front end of our application. Also, there will be a RAG chatbot integrated in the front end of the website, where users can utilize it to know me better. For the chatbot, we use technologies like Streamlit for front end of the chatbot, HuggingFace for LLM, Langchain, and a VectorDB for converting text into embeddings and perform semantic search to fetch top results from vector database and then generate a response. Here is the summary of tools and technologies that have been displayed on the screen. In data collection and pre-processing, we are going to utilize our own website to web scrap the data and also resume using tools like Beautiful Soap and PyPDF. And then we clean the data and vectorize it into embeddings and then store the pre-processed data into vector database. We utilized Beautiful Soap to scrap data from portfolio web page. We have attached a code snippet to scrap data from portfolio web page. This is the image of pre-processed and clean data. Today, I'm going to walk you through the implementation of our RAG pipeline, which stands for Retrieval Augmented Generation. This pipeline is crucial to our chatbot's ability to provide accurate and relevant responses. It involves several key steps: data loading, text chunking, vector embeddings, similarity matching, and response generation. First, foremost, we create a virtual environment and activate it. Next slide, please. After that, we install all the dependencies that are mentioned on the screen. Now, let's start with the vector database implementation. For chatbot, I chose Chroma as the vector database due to its compatibility with Langchain and the specific requirements for handling portfolio and resume data. This decision supports efficient data retrieval based on semantic similarity, which is crucial for delivering accurate information. So firstly, importing all the required Langchain dependencies and API key from HuggingFace Hub. I'm storing my HuggingFace key in Streamlit secret file so that I'm importing Streamlit and loading it to access the API key. Here is a sample dataset which I have converted into PDF format for easy text extraction. Now, step 2 is PDF data loading. I used PyPDF loader from Langchain to download the resume dataset PDF. This step ensures that all the text content needed for the vector database is accessible. Now coming to step 3, text splitting. With the recursive characters text splitter, I divided the loaded in text into manageable chunks, optimizing them for embedding process. Step 4 is text embedding using HuggingFace embeddings, specifically the sentence transformers all mini LLM model. I converted the text chunks into vector embeddings. This transformation is key into embedding semantic based data retrieval. And then generated embeddings were stored in Chroma vector database, which is set up with a directory to persist data. This database structures the data to facilitate quick and efficient similarity searches. Now let's proceed with chatbot development. For chatbot, I designed an interactive user interface using Streamlit that enables user to submit natural language queries about me. This interface is intuitive and tailored to facilitate easy engagement with the system, ensuring users can readily seek information based on my resume. Now let's proceed with the implementation steps. Firstly, let's initialize the environment and dependencies by importing necessary libraries such as Streamlit, Langchain, PySQL3, and .env for environment management, and loading environment variables like the HuggingFace API token to authenticate and utilize HuggingFace services. Now, setup of the language model and vector store by initializing the HuggingFace embeddings model to process and embed textual data, and then configure Chroma as the vector database to store these embeddings, which facilitate efficient retrieval based on semantic similarity. For step 3, set up the retrieval QA system from Langchain, incorporating the HuggingFace language model. Here I'm using MetaLlama 38B instruct model. Let's configure the retriever within the system to fetch the topmost relevant entries from vector database, ensuring responses are precise and relevant. Now define a custom prompt template. Here is using directive prompt based prompt pattern, which will guide the language model on how to generate appropriate responses based on the queried context and user interaction directives. Here is how this prompt pattern helps in generating responses. Then implement a function getResponse that takes the user questions, processes it through a retrieval QA chain, and extracts the answer from the model's output. This ensures that the responses are not only accurate but also tailored to the user's specific inquiry. And then customize the Streamlit layout and remove unnecessary white space and add aesthetic elements like headers and sidebar messages. And creative interactive elements such as input and buttons to clear the chat history, enhancing user interaction. And finally, set the user interaction flow using stchat input. Users input their their queries, then the system processes these input, retrieves relevant information, and the language model generates responses which are then displayed back to the user in the chat interface.
Let's run our chatbot application. To launch our app, make sure you have executed the vector embeddings implementation code first using the Python vector embeddings.py. Now let me show you our chatbot. So here is the chatbot where I have asked multiple questions like what is my work experience and what are my technical skills. So it has provided pretty accurate responses. Now coming to the RAG pipeline evaluation. So precision, relevance, entity recall, noise robustness as retrieval metrics we are checking. And then we are checking faithfulness, answer relevance, information integration, counterfactual robustness, negative rejection as generation metrics. And then finally, we are checking the response time of the system as latency metrics. And then we are utilizing all these metrics to evaluate the RAG pipeline. Here is the output we got. So we got recall score of 75%, entity recall of 100%, BLU score of 90%, faithfulness of 69%, and very less latency and noise. Now coming to the improvement strategies, we define to fine-tune our model on our dataset using the unslot LoRa adapters. To fine-tune the language model on a domain-specific dataset to improve the accuracy and reliability of the generated answer, let's start by installing all the required dependencies. Now initializing the model training parameters such as max sequence length, data type, and 4-bit quantization for the training parameters. Now adding the LoRa adapters, so we only need to update only 1 to 10% of the parameters. Now coming to the data preparation step and the LLM prompt setup. So to upload the data set, we have already done it on the HuggingFace hub. Here is the snippet of the fine-tuned LLM model data set, which we are going to use. It has a set of instructions and some expected output of that particular instruction. Now coming to the LLM prompt, here we are providing a template where it will take the instruction and it will put the generated response of the LLM in this format, and then utilizing this particular two fields and adding those two fields into a column called text. Now, after loading the dataset, we are printing the dataset to confirm all the values. Now coming to the training part of the model, we are using supervised fine-tuning technique. We are initializing all the model parameters, tokenizer, training data set, as well as the main particular column that is text, from which the data is coming. And then we are defining the maximum number of steps. Now running the trainer up to 60 maximum steps as we defined earlier over here. Now, after training the model, let's check the inference of the model by providing the instruction and putting the output value as blank, which will be generated by the fine-tuned model. Now, after training and inference, saving the model locally as well as on the HuggingFace hub. Here is the screenshot of the HuggingFace hub where I have fine-tuned the model and saved it with the name Llama 3.1 fine-tuned model. Now, to use this model, we will be initializing the HuggingFace hub LLM with the fine-tuned model by mentioning the repo ID as the model name and with the username, and also defining the temperature and the maximum number of token it will be generating. Now let's start with the application demo and testing. So here's my application. This is the React made using with the React, HTML and CSS. This is the homepage of the application where it is defining all my expertise in all the technologies I have worked on. Here is my education and certification section where I'm defining all my degrees and showing all my certification which I have gained. Here's my experience section where it will be defining all the internships, work experience in MNC and teaching assistant experience. Now coming to the project section, this is the projects I have done. So it will be used to define all my projects. Now coming to the contact and resume, here is my contact applications you can utilize, and also it will be able to download my resume from this button, and also you can see my YouTube channel. Now coming to the final part of the chatbot application, that is chatbot of the application. On clicking this page button, it will redirect to the chatbot. Here's my chatbot, and I can ask multiple questions. I can here's the multiple questions I can ask. It will generate a pretty accurate response as per my resume. Now coming to the Anmol's portfolio, we utilize the same technique for Anmol's portfolio as well. Here we are defining her education and certification, then experiences, then coming to the project part. And here is the contact and resume. And similarly, we have integrated the chatbot here as well, which has the data of Anmol's resume. And also we can utilize it to ask multiple questions as we want. So this is it, the demo of application. We have tested our application thoroughly with the simple queries such as what makes our a standout candidate, what are my skills, and it has provided a pretty accurate responses. Now coming to the complex queries, I have asked multiple questions in one go, like describe top 3 skills and what are my years of experience. So here is a answer provided for both the queries. And also I've asked like complex queries like what are my accomplishments in TD Bank, and tell me why I should get hired by describing me in one word. So this has provided a particular accurate response. I've also tested this model using the irrelevant and out of scope queries, just providing randomly a string or just asking an out of scope question like what movies I watch or what are my travel plans. So it has provided a pretty accurate response, like it has no information about the movie's preference and no travel plans are described, as well as this is not this is a non-resume related query, so it has handled accuracy. And I've also tested the model with the misspelled queries, like asking what is the Koshki's professional experience. So it has provided a pretty accurate response of the misspelled queries as well. Now coming to the deployment plan. So we have deployed the application using the Netlify and Streamlit. So we firstly deployed the chatbot app using the Streamlit cloud, and then we have integrated the chatbot app into the portfolio website, and then finally deploying the portfolio website on the Netlify app. Here is our application URL and chatbot URL. So we have specifically also provided the chatbot URL with the application URL, but it does not need it to be go through it. It can be also accessible with this particular button, Talk to my bot. Now coming to the future plan, as we look ahead, we plan to add more interactive features such as blogs, tutorial sections. We could also expand the chatbot capabilities, for example, scheduling appointments, integrate with the social media, and implement a testimonial or recommendation section where clients, colleagues, or user can provide feedback or work on the service. Our long-term vision is to create a comprehensive voice-based AI-powered assistant. Coming to the conclusion, our project is a personal portfolio website with an integrated reg chatbot. It's a practical application of course concepts and a valuable project for showcasing our technical abilities. We are excited to present and receive feedback, and we are also looking forward to future improvements. Thank you.